This video will review how to find a percent under a value in the normal curve. So recall that beef cattle is normally distributed and had a mean weight of 1,152 pounds with a standard deviation of 84 pounds. What percent of steers weigh under 1,200 pounds? So from the last video, we drew our normal model and we labeled our standard deviations and mean. So I'm going to use this picture to help us figure out the answer to this problem. So we're concerned in the percent of steers under 1,200 pounds. So in the picture, I'm going to start off labeling where the 1,200 pounds would be. It's going to be somewhere between the 1,152 and the 1,236 pounds. So again, I'm just going to guess it's probably about right here. This is my 1,200 pound steer. And we're interested, according to the problem, in the percent of steer that are under that value. So for me, I'm a very visual person. I like to draw pictures. So I know I have to be looking at this percent. So the value is below that 1,200 pounds. So in order to do this, we need to use our normal curve percent table. This is located in your textbook. It's also posted in Blackboard. So when we look at this table, notice the first thing we need to have is a z-score. So we need to change our value to a standard normal z-score. So we need to change that 1,200 pounds to a z-score. So remember, the z-score formula is the value minus the mean divided by the standard deviation. So we know the mean is 1,152 pounds, so I'm going to fill that into my formula. And we know our standard deviation is 84 pounds. So again, I'm filling that into our formula. So the value that I'm interested in is the 1,200 pounds, because that's what I'm trying to change to a z-score. Now it's a matter of computing this z-score. So please make sure when you're typing this into a calculator, you type it in correctly. Either do it as one whole problem with parentheses in the numerator, or do it as two separate problems. I'm going to do it as two separate problems to demonstrate the importance of hitting enter. All right, so we're going to do the numerator first, the 1,200 minus the 1,152. We're going to take that total of 48 and we're going to divide it by 84. Z-scores normally are rounded to two numbers after the decimal. So we're going to round to the 7. So remember, when you round, you look at the number after. The 1 keeps the 7 a 7. So my z-score is 0.57. Which makes sense according to our picture because we knew it was between 0 and 1. That's why we draw the picture. That's why I draw it, so that way I can make sure my math is correct. My z-score has to be between 0 and 1, which we saw it as 0.57. Now we know the z-score, we go to our standard table to find the percent. So we're looking at our standard normal probabilities. We're looking for a z-score of 0.57. So notice we're going to start over here, the z-score. We're going to look for 0.5 along the side here. All right, so here is 0.5. But remember, our z-score was 0.57. So we're going to go across this 0.5 row until I get to the 0.7 column, which is right here. So notice the 0.5 and the 0.07 intersect to to find the percent. So 0.7157. 0.7157. One thing I will stress, notice if you look at the pictures here, this table only gives you probabilities of areas below a value. So for my answer here, this is the percent underneath 1,200 pounds. Now we just need to change it to a percent. Remember, when you change it to a percent, you multiply by 100. So my percent of steers that weigh under 1,200 pounds is 71.57%.